Okay, text classification. So lecture notes number 8. So this one will talk about how do we manage our document by classifying and also by clustering them for easy retrieval later on. So in the previous era, where the document are stored based on the index term in order to retrieve them later on. So with larger collection, we need to label the document. So imagine that for each document that we have, we should be able to label them based on the topic or based on the concept or based on some concept that we extract from the content of the document. So each of the document must have a unique identifier, and for the previous system, they does not allow finding document on a subject and or topic. So basically, each document they have like unique identifier only. So this is why, because normally they put this one in the database. So database require unique ID, and also they will type in the title. So if you only type a partial title of the document, you will not be able to retrieve them, although part of the title you have key in. So that was the problem that we have long time ago for the classical one. But for us to be able to search document on a subject or topic, we should be able to group them based on the common topic, or we could label them using meaningful label. And for each group of document, we can classify them according to the content of the document that we have. Let me correct this one first. So that's why text classification is very important, because it's enable us to classify document belong to which categories, and then it's easier for us to retrieve the document later on based on the category. In most cases, the process of grouping them or the process of classifying them, we can use category or classes, but both belong to the same task, which is the supervised task. We call it supervised because we have label. The label is used to guide us to classify them. So this is called supervised task. Because we are performing categorization and classification, we have label, okay, or classes or categories. Okay. If we do not have any categories, then we can group them or we can cluster the document based on the content. So there is no label needed. There is no classes needed like this one. This is text classification. And when we do not have any label or classes, we call it clustering or unsupervised tasks. Unsupervised tasks meaning we do not have any guidance on how to group them. So we group them based on the content only. Okay. So for text classification, this is a means to organize information for us to retrieve later on. So for a large company, if we have thousands of documents, so we want to manage them for retrieval later on for business decision. So it's very important because every day we will have more unstructured document given to us. Even in our faculty, for example, every year we produce thesis. So if we want to manage this thesis, we need to be able to classify them or be able to cluster them based on the content or based on the classes that predefined before we manage the document. Okay, so we need to have a program, or we can say algorithm, that learn pattern in the data. So this is the definition of machine learning. Machine learning is just an algorithm that used to learn the pattern in the data. So in our context, we are looking at the content of the data that exists. So we are learning the content of the data. So the content can be used to predict the classes for the newly given document that we have. So for example, if we have 5 new documents, so we can look at the content of the document, then we can predict what classes they belong to. Okay? So in order to organize our data, we have 3 basic type of algorithm. The first one is supervised, second one is unsupervised, and third one is semi-supervised. So for this one, we have classes, right? This one, no classes. And this one, majority has no label, but some of them have. Okay, so we will look into this too. So the first one is supervised learning. So since we have the classes for the input document, we will be using the machine learning, and we use the data to train them. To train them, meaning that we want to learn the pattern inside the document. So we also have unsupervised, in which we do not need any training data, but instead we are looking at the similarity between the document to cluster them. So we can use the clustering or neural network or IDA, ICA, independent component analysis, in order to group them. Okay, so we will look into some of these techniques. We also have the semi-supervised learning, where we have small training data, which means we only have a small portion of the data that has label. So we combine with larger amount of unlabeled data. Okay, for the text classification. So in the text classification problem, we can define them as following. So meaning that we have a set of collection of documents that we want to use as a training for our machine learning algorithm. We also have label called classes. So we have class 1, class 2, up to L, set of L classes. And then we want to build a model that can formulate a binary function in which the document and the classes can be associated to produce 0 or 1, in which we want to know whether the document J that belong to set of document, and also class P that belong to the set of L classes, whether they have 1 value, which means that that document belong to that class, or 0, which means that the J document is not a member of the P class. Okay. So we want to define this function. So this function can be defined by looking at the content of the document that we have. Okay, when we talk about the supervised algorithm, we also have a few conditions. So we could have multi-level or single level. We can illustrate here. So when we say binary means we have only two classes to deal with. So normally this one will give you higher accuracy because we only have two classes here. Okay, we also have multi-class classification in which we have more than two classes. So for this one, we have lower accuracy because we need to learn different pattern for more classes here. So a bit complex here. Okay? And we also have this multi-level in which one image can be categorized or classified into two labels. So this is multi-level. One or more labels are assigned to each of the document here. So that is the definition of multi-level binary classification and multi-class classification. So both this is single level. So this is multi-level. Okay. So the function that we want to formulate here or to develop is depends on the content of the document that we have. So what we want to do is when we have a binary classification, we will have binary function to associate the document with the class. So the relationship between the document and the class can be exact or could be yes or no, or could be maybe, or depends on the degree of membership. Okay? So for the classical set of theory, for example, the classification can be divided into two, which is not tall or tall. So there'll be no gray area here. But for the fuzzy set theory, we will have the intermediate, which is the gray area here. So we only have not tall and tall, but we have this one also. So this is the, what we call it, the gray area for the degree of membership. Okay? So it's near to here, that means high degree of membership for the tall. If it's near to this line, so high degree of not tall membership. So this is fuzzy set load theory. But for us, we will look into this because this one is a lot of algorithm use this one, and this one is only to accommodate the uncertainty of the classes due to several factors here. Okay, so we will look into this, which is exact yes or no only. And for the, let me bring forward first. So for the supervised text, we will have a few algorithms here. So some of you have studied this, some of you belum lagi. So like Manan, you have studied this one, kan? So decision tree, we have nearest neighbor, we have the relevant feedbacks, nav.js, support worker machine, and ensemble. So all this you will learn in the advanced machine learning, or advanced data mining. So more to learn. This is for the supervised. We also have the unsupervised. So we have clustering, naive text classification. So for clustering, we have two types: partitional. This is non-overlapping. We also have overlapping clustering, which is the agglomerative clustering. So we have k-means, bisecting k-means, and also we have for the agglomerative clustering, we can divide them into single link method, complete link method, average link method. And for the knife text classification, they are based on direct matching only. So this is basically using the technique that we use for matching query and document. Okay, so we use vector model. So this is similar to looking at the query and then how similar is the query to the document that we have. Okay, so let's take a look at this one first, which is the clustering. So for this unsupervised, we do not need the label, right? So our task is to cluster them. So how do we do the clustering? So we will look into this part first, the clustering. First, we look at the partitional clustering. For the clustering, the input that we need will be the set of document, and also we do not have any label. So the task of the model is to separate the document into subset or cluster automatically. So this is what we call the clustering test. So for example, this is just the illustration. For example, we want to cluster the hotel web pages in Hawaii. So we have input collection, and then if we have k equal to 5, k equal to 5, meaning that k cluster, 5 cluster. So when we have 5 cluster here, so each of the cluster can be renamed. Okay, so we have this additional name. So this could be the label for this particular cluster. So in the individual cluster will have individual newly generated label here. Okay, but the process that we want to look at from here, how do we form the cluster here? Okay. Okay, so in the previous example, we have the class label here generated. So we can use the class label to generate the rules. And in most cases, we can have the that we have here are generated by the content based on the content of the document that we have here. Okay, so this is the label that generated automatically. They might be different from labels specified by human, and this is much lower quality because they are based on a few aspects only. And if we compare with human being annotation, the expertise annotation of the document is better because they know the content of the document. Okay, so thus solving the whole classification problem with no human intervention is hard. Okay, so that's why it's better to up to this level only. So where we just cluster them, and then based on the content of this cluster, when we have new document here, so we assign to either one of these document depending on how similar they are. Okay, so let's take a look at the first one. K means clustering. K means clustering. K refer to number of cluster. Means refer to the center of the cluster is obtained by taking the average of distance of all members from that cluster. Okay, So this is the number of cluster. This is referring to how the center is being computed based on the average of all the distance from all the member of the cluster. Okay. So for a k-means clustering, what we need to do is to key in is number k of cluster. So we can generate 3 cluster, 5 cluster, depending on your requirement. So each cluster represented by its document centroid, which is the center. So this is the algorithm for k-means algorithm, in which the task is to partition document among the k cluster, each document assigned to the cluster with the closest centroid using the Euclidean distance. Okay, so this is the Euclidean distance. So the distance is measured by taking square root of summation of the differences between the element in the vector for each of the document that we have. So we take the difference of each of the element, take the square here to normalize the negative value, and then sum up all the differences and take the square root to make it a small number. Okay. And then once we perform the assignment of all the member to the center, then we need to recompute the centroid in order to redo the whole process. We redo the whole process until there is no centroid changes. Okay, so this is the basic illustration. For example, we have k equal to 3 here, and we pick randomly the center by picking the one of the data here. Okay, and then what we do is the remaining of the data here, we assign them to the nearest class center. So for example, this one is nearer to the blue one, so I put this one blue. So for this one is nearer to the green one, I assign green. This one nearer to here. The red one is nearer to red one. So once I form this, then once I form, okay, I have this cluster. Let me erase first. So I have this cluster. So if you look at this one, this is the all center. So I need to recompute the center here to here by taking the average of all the value that we have in this domain. And then similar to here, the center could be here and here. So what we do is, once we recompute the centroid, then we will perform another calculation. We assign this one to the nearest one. We assign all the data to the nearest one and so on. So the illustration will look like this. We start with this, and then the centroid is slowly moving to the best position. So this is the best position because in the next round, the centroid is still the same. So we stop here. So we need 6 iterations. That means 6 assignment of the other data to the centroid. Okay. So how do we actually apply this one in text document? So this is our text document. We have the content T1, T2, T3, T4, and the number that we have in this matrix can be considered as the weightage or the TF-IDF. But over here, I'm using a number to simplify the calculation. So let's suppose we want to have 2 clusters. So I pick randomly. I pick a 7 document. So I pick randomly. Okay. So this is center 1 and center 2, center K1, center K2. So what I will do, I will pick my document number 1 I want to decide whether I want to put in cluster 1 or cluster 2. So before I do that, I need to compute the distance between D1 to D3 and then D1 to D6. So I compute this. So this is using the Euclidean distance, where I take the square root of the summation of the difference of the square difference. So this is 2 square, this is 2 square, this is 0, this is 2 square. So basically I'm taking the 2 square, this is 0, and then 2 square. I add up all this value and take the square root, I get 3.64. So this is the distance between D1 to D3. I repeat again, from D1 to D6, but the distance is 5.1. So we know that document 1 is nearer to the 1. So I will put this document 1 together with document 3. They belong to the same center, the same cluster. So I will do the same for the rest. So document 2 is nearer document 3. So I put document 2 inside the same cluster, which is K1. I repeat for D4 nearer to document 6. So I put in cluster 2. Document 5 nearer to document 3, and document 7 nearer to document cluster 1. Okay, so if you look at the process from the beginning, I start from D1, D2. Actually, we also need to do for D3, but since D3 is there, so basically I can skip that one. I skip 4 and then 5, and then I actually need to do D3 and D6 and D3 and D6 and D6, but no need because they are actually the same. So I skip and so on. So it's only the first iteration, the first round. Okay, so once I have this cluster, then I will need to recompute the average, the center. So what I do is I take the average. So for this cluster, I have this 5 documents. For cluster 2, I have 2. So what I need to do is I take the average. For document 2, this is the center. And for for cluster 2, this is the center. For cluster 1, I just need to add all this value and take the average. Okay, so this is your new center. So you repeat again for the second iteration. So you do the same until there is no changes. Okay, so we start all over again. So this is your new center. And then we do again. And we decide to go to here or to the cluster 1. So we repeat for all. Okay, so we will stop when there is no changes of. Okay, so that is the idea of K-mean clustering, in which you pick random K center, then you assign the remaining document to the nearest center. Once you have completed all the document, then you recompute or quantify the new center by taking the average of the membership of the cluster. Once you get the new center, you do it again, and this will be repeated until there is no changes of center. Okay. They have also a variant of k-means called bisecting k-means. So in this case, we are breaking it into 2. If k equal to 2 means we divide them into 2. So the initial step is assign all documents to a single cluster. Then you split them into 2. Okay, and there'll be a stopping criteria. For example, you stop splitting when the number of document is equal to certain number. Okay, for example, like this. Okay, bisecting using k equal to 2 means we split the cluster into 2 clusters, and we will stop the splitting when we have 4 or less number of documents. So, for example, we start with 15, so we divide into 2. Okay, and then for 8, we divide into 2, so we stop there. And then this one 2, 5, then we have 5, need to split again into this. So basically, in this one we have 5 clusters for bisecting k-means. Okay, any question? So that is the idea of the k-means clustering. So for this clustering, there is no overlapping cluster because all of them have a separate cluster. Okay. The second one is called agglomerative hierarchical clustering. They call it HAC, hierarchical agglomerative clustering, because they allow for overlapping, and the cluster is defined as a dendrogram. Okay, let me show you. Okay. So the goal is to create a hierarchy of cluster by either decompose a large cluster into smaller one or combining them. So let's take a look at this one. So this is similar to bisecting. Let's take a look at this one. Okay, so the general algorithm for HAC is that we will have a set of n documents to be clustered. So for us to start, we need to compute with the n times n similarity distance matrix. And then we assign each document to its own cluster by combining them. Okay. So, and then we recompute the distance between newly formed cluster and the old cluster. Okay. Okay. And we repeat this until we have one cluster. Okay, let's suppose we have this technique also depends on the method that we use for cluster distance. We will go over this later on. Okay, for example, we have this. This is the formula for the single link. Okay, let me go through this one. Okay, this one is given 2 different cluster. We take the distance between these 2 clusters based on the minimum distance between 2 documents belong to different cluster. So for this one, the complete link between 2 clusters is determined by taking the maximum distance between 2 documents within different cluster. And then for this one, average, basically we are taking the average distance of all the member in the cluster for all the documents and take the average. Okay, let me show you the basic one. Okay, so we start with cluster of individual point. For example, this one, how many we have? 3, 3, 4, 12. So we have 12 data here. So we need to start with each document will be considered as individual cluster. So our task is to determine which document that we should form. which document should we combine to form the cluster. So before we can do that, we need to get this proximity matrix. So that means we need to know what is the distance between P1 and P2. And the rest of them. So for this one, we don't need, because they are referring to themselves. So we don't need this one. Okay. So based on the distance of all of this, so we can use the Euclidean distance. So we take the smallest one and then combine them. So for example, if we have P3 and P4, they are the smallest value here. So that means we are combining P3 and P4. Now I have 11 clusters instead of 12. Okay. So for example, if we have gone through a few phases of this, so basically we have this. So this cluster are formed based on the 12 document that we have. And then it started when we find the smallest distance, and then we start combining them, and then we will have this. Okay. So we will continue combining the cluster until we have only one cluster. Okay. For example, if we found that C2 and C5 are similar, then we combine them. And what happened to our matrix? So since we are combining C2 and C5, that means we need to find the center of this and then recompute again with the other distance. So now we have 4, then we need to compute the distance again. We'll keep updating the proximity matrix. So we will continue until we have one cluster. Okay. So how we use this technique in clustering our document. So this is just the illustration of how do we compute the sum between two clusters. Single link refer to the smallest distance between two documents belong to different clusters. Complete link refer to the maximum distance between two documents belong to two different clusters. Average link refer to the average distance of all the members from different clusters. And centroid referring to the distance between the center of two different centers. Okay, so which one is the best one? So it depends on the document that you have. Okay, so let's start. How do we actually use this hierarchical clustering? Let's suppose we have this document. So we have 4 documents, right? So we need to construct 4 times 4 proximity matrix. Okay, so we have this. So that is our distance. So remember that the distance, we can use the Euclidean distance to find the distance between two separate documents here. So we found that this is the smallest one. So we combine document 2 and document 3. Okay. So once we combine, so that means the center will be different, right? So we need to take the average. So this one is 1.5, 1.5, 5, 2.5. Okay. So the next line, this become this already. So become 2. We have new center here. So we need to form 3 times 3. Proximity matrix. Okay, so now based on that, we pick the lowest one is 3.2, and so that means we combine. So now at this stage we have 4, right? So this is 1, 2, 3, 4. So in the previous one we combined 2 and 3, and then for this one, since we have 3.2, so that means this one is combined here. And since we only have 1, so we combine this one. Okay, so as you can see, this is like a tree, and they call it hierarchical agglomerative clustering. Okay, so this is the last one. Okay, so that is based on the distance between the centroid. Okay, so what if we repeat this two? We say that generate 2 clusters with the following center using single link, which means the minimum. Okay, so for example, like this, from this, because at the beginning, the distance between the cluster will be just the distance between the document. One document is considered as one cluster. So there is no other document in that particular cluster. So we just use this one, okay? So we combine 2 and 3. Okay, then we have this one again. So since we have 2 and 3, so now let me illustrate. So now we have 2. This is based on the previous one here. We are combining 2 and 3 because of this value. Okay, now on the next we have 2 plus 3, and then 1, and then 4. Okay, so the center of this will be recorded, and then we have new center. So that means, okay, for example, to the distance between these 2 clusters, I need to know whether I want to pick this or this. But since we are using single, so that means we pick the minimum distance between these 2. Similar to the distance between this cluster and this, we want to know which distance we want to use. Okay? So this is the distance between document 1 and this cluster. So we will pick the smallest one, which is this one. So the distance between this will be 1 and 2, which is 3.32. Distance between 1 and 4 will be 6 only. The distance between 2 plus 3 and 4 would be this, which is between document 3 and 4. So this is 8.72. Okay, so given the distance here, 6, 3.32, and 7.2, 8.72, then we pick this one. So we are merging and also the combined 2 and 3. Okay, so you pick the color. Okay. So if I remove this, erase everything. So this is the distance that we pick for 1 and plus 3. This is the distance we pick for the distance between 4 and 2 plus 3. And then to reach the final minimum again, so we pick 3, so that means we have -1 and plus 3. Okay, because we have more, but if you have different so this just some of the exercise. So this one is given the distance method. So the task is we have 2 and 3. So they ask you which cluster will be combined next by using the simple and complete link. So the kind of question that will be asked in the final. Okay, so based on this, so we need to compute the one. Okay. So that means this is for, so that based on this the this in 1 and 2. Okay, so that is for single. For this link is basically random. Distance which class you want to. Okay, any question? For text classification, we are using distance method also. Okay. Classification, they said, okay, no training, because we need to compute the distance. So and also and to associate one or
Prof. Suara Prof. Putus-putus, Prof.
yes. Oke, siapa? Oke, boleh Kak? Masih lagi?
Ada oke sedikit.
I repeat that. So naive classification masih putus-putus. Oke.
Oke, sudah. Cuma tidak ada nampak
Oke.
slide.
Resume. Okay. So for this naive application, we use the document and also the label that they have, but the content, we are using the class level to measure the distance between the document and also the label. So this for permit allow for pass because we're using the equivalent distance. Okay. For example, here we have the collection of document to classify, and also we have the label. So for each of the document, we use the weight vector. So this is similar to earlier study, and also for each class, they also have the label. They also have the weightage for that class label. Okay. Each of the document that we have in the set of document, we are trying to associate with the class label that we use using the cosine function here. So we have studied this one, right? Last time, the class here is used as the query, and this is the query here. But now we use the class. Okay. Okay. For instance, suppose we have the 4 document here, and we have classes A, B, C, and all these classes A, B, C, they have labels. Okay. So for us to determine, for example, to which classes, we need to compute the distance in this document with the label that we have here. So this is similar to what we have done before, in which this could be considered as your query. But now this is the label, right? So we computed the distance and tell whether they belong to class A, B, and C by looking at the minimum distance of between the document and the labels that we have. Then we can determine the classes, the class, which class they belong to. So we use this formula. Similar, right, to our previous situation, the previous environment that we have. But now we are using a label as a keyword that we label the class, and we use that one to say classes can be assigned to the document that we have. So this is naive text, and because the label is enough to provide information which class they belong to, naive. Okay. So this one, although not very high accuracy, because it's on the label that here, right? Okay. So for this one, if you look at this one, we do not need to train the model. We just use distance method to determine which class they belong to. That's all. That is the end. So this session talk about unsupervised machine learning, which is the clustering. So the clustering, we have partitional, also hierarchical clustering. So there'll be one assignment. This I will post. So I hope you all already completed your assignment